In this recording, we are going to discuss the CSEC Math Paper 2 of the May 2024, number 7, which deals with patterns and sequences. In the previous video, we discussed part A already to construct the fifth figure. And we noticed that each subsequent figure, the number of hexagons increased by 2. So we're going to part B now. It says the number of regular hexagons H. The number of hexagons H. So H stands for number of hexagons. The number of sticks S. S stands for number of sticks. And the perimeter of each figure, P for perimeter, follow a pattern. So the values for H, S, and P for the first 4 figures are shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. So we're going to do a recording for each of the parts, a recording for 1, for 2, and for 3. Now it says, for the first 4 diagrams that are shown in the table, the values of H, S, and P were given. So here they are. Number of hexagons for diagram 1, the default diagram is 3. And the number of sticks is 15. And the perimeter now is 12. And what else is shown in this table there? Right. So it's up to perimeter. And for 2 is 5, 23, and 16, respectively. And for 3, 7, 31, and 20. And 4 now is 4, 9, 39, and 24 for figure 4. So now we have to complete the row, the number of hexagons, and the number of sticks for diagram 5. So we can follow the pattern. There are different ways you can do that. But for a situation like this, you can calculate for diagram 0 if there is a diagram 0. There isn't a diagram 0, but theoretically you can create a diagram 0 and go down by 2. So 0, diagram 0 is 2. No, 3 minus 2 is 1, sorry. Diagram 0 is 1. The number of hexagons for diagram 0 is 1. And it's increasing by 2. So then you can jump the gun a little bit and go to part 3 and deduce the formula for n. All right, part 3. It's asking for the formula for n for number of hexagons. And that can be easily written as 2n plus 1. One may ask, where did the 2 come from? The 2 is serving like a gradient because it's almost like a linear expression you are deducing. each subsequent number of hexagon is increasing by 2. And 1 now is like the y-intercept, what it started with. So it's like a linear equation, like a straight line, mx plus c. Now you can test it now. N is the number, the diagram number. So 2 1s are 2, plus 1 is 3. 2 2s are 4, plus 1 is 5. So you can easily calculate the number of hexagon for figure 5. 2 5s are 10, plus 1 is 11. So basically, to answer part 1, we jumped the gun and went to part 3 automatically. Let's see if this applies for the number of sticks. 23 subtract 15 will give us 8. 31 subtract 23 will give us another 8. 39 subtract 31 will give us another 8. So it seems that 8 is constant. It's like a gradient, an increase of 8 all the time. So that gives you like a linear sequence, a linear pattern. Now, with what number it started with. So for diagram theoretically 0, you can subtract 8 from 15 to give us 7. And then we can test it to see if it applies for all. So the gradient is 8, because it is increasing. The pattern is increasing by 8 constantly, starting with 7. So let's test it. 8 1s are 8, plus 7 will give us 15. 8 2s are 16, plus 7 will give us 23. 8 3s are 24, plus 7 will give us 31. 8 4s are 32, plus 7 will give us 39. So 8 5s are 40, plus 7 will give us 47. And we can apply the same for the perimeter. Let's see if the difference is constant. The difference between successive terms is constant. 16 minus 12 is 8. It's 4, sorry. 20 minus 16 is 4. 24 minus 20 is 4. 28 minus 24 is 4. So 12 minus 4 will bring us down to 8. So we answer in part 3 one time. And here it is for the perimeter. 4 1s are 4, plus 8 will give us 12. 4 2s are 8, plus 8 will give us 16. 4 3s are 12, plus 8 will give us 20. 4 4s are 16, plus 8 will give us 24. 4 5s That 20 plus 8 will give us 28. So therefore now, once you determine that the difference is constant by subtracting successive terms, you can use that difference to act like as a gradient to multiply to n, and you basically subtract that gradient from the first number that you see for number 1 to get a theoretical 0 to get the starting point. 2 from 3 will give us 1. 8 from 15 will give us 7. 4 from 12 will give us 8. And the increase is by 2 constantly here for the number of hexagons. The number of sticks, the increase is 8 constantly. And for the number of perimeter, or the perimeter, the increase is 4 constantly. And then we can use that formula now to solve for the missing part. So we'll do a separate recording for 2 because we automatically answered 1 and 2 in one presentation. So anytime you see you get a situation like this, subtract the successive terms to see if the difference is constant. Once the difference is constant, you just subtract from the first one to get the starting point and use that constant difference to act like as a gradient to multiply to n, and plus the value you got when you subtract it from the first number, that will be the starting point. It will act like c, almost like the y-intercept, and then you can use that now to determine successive parts of the question.